Hi, so we'll be learning about two more page replacement policies today. So first one is LRU. So its full form is least recently used. So what does it mean? It means the page who has not been touched for longest time. Okay, has not been touched for longest time will be replaced. For longest time will be replaced. Okay, so this is your page reference sequence, and your main memory has three frames. Okay, this is your main memory and it has three frames. So first CPU request first frame, sorry, first page, so it will come here, and then it will request second, it will come here, and then it requests third, it comes here. Now it again requests one, so one is already present, so there will be no page fault. 1 2 3. Now here also you can see no page fault as CP requested 2 and 2 is already present. Now CP requested 4. So now which one will be replaced here? So as you can see here, uh, CPU requested page number 2 at this point. So if CPU has requested page number 2, then it means the page number two's contents or the instructions that were written in page 2 has been recently executed by the CPU. Okay, so therefore 2, whenever you see that CPU request a page, then it means it has been used. Okay, so it is touched recently, and as you can see 1 is also there. So before 2, 1 was also touched, and before 1, 3 was touched. So out of 1 2 3, who has been touched for a very long time earlier? So it was 3. Okay, 2 was recently touched. So therefore 3 is the one who has not been touched for longest time. So therefore 3 will be replaced here. Okay, so 1 2 3, 3 will be replaced by 4. So now 1 2 4. Now you can see it request 1, so 1 is already there. 1 2 4, 2 is already there. 1 2 4, it requests 3, and who are the candidates? 1 2 4. So you can see here 2 is referenced here, 1 is referenced here, and 4 is referenced here. So 4 is the one who has not been touched for the longest time. So 4 will be replaced here. So now you can see it will be 1 2 and 3. So now what? 4 is requested, CPU requested page number 4, but 4 is not present, so this is a page fault. So now which page will be replaced out of 1 2 3? So 3 was used here, 2 was used here, and 1 was used here. So 3 is just recently used, 2 was used before that, and 1 was used even before that. So 1 will be replaced here by 4. So this is your the process of how LRU page replacement policy works. Here you can count the page faults. So 1 2 3 4 5 6. Sorry, these are not okay. Sorry. So 4, this is not a page fault. This is also not a page fault. This is a page fault. So this is 5, and this is also a page fault. 6. So there are total 6 page faults here. So 6 out of 10. This is your page fault ratio. Okay. So now let's see another strategy or page replacement policy called MRU. And we are using the same example for MRU as well. And it is just the opposite of LRU. It basically means that page will be replaced who is used recently, okay, who is used recently will be replaced. Okay, will be replaced. So initially there in the main memory there was no page and CPU requested page number 1, so page comes, and then page 2 comes, and then page 3 comes. Now CPU requested page 1, so 1 is already present. This is not a page fault. Okay. And 1 2 3, so CPU requested 2, 2 is already present. This is also not a page fault. Now 1 2 3, now CPU requested 4, so from 1 2 3, so 2 was used here, 1 was used here, and 3 was used here. So who is used recently? 2 is used, so 2 will be replaced by 4. So 1 4 3, so CPU requested 1, 1 is already present. This is not a page fault. Now 1 4 3, CPU requested 2. Now out of 1 4 3, who is used recently? 1 is used recently. Okay, so it will be replaced by 2. So 2 4 3. Now from 2 4 3, uh, who is used recently? 2 is used recently, but CPU requested 3 and 3 is already present, so this is also not a page fault. 2 4 3, CPU requested 4, 4 is already present, this is also not a page fault. So you can see here 1 2 3 4 5, there are how many page faults? So there are page faults 5. And what is the page fault ratio? It is 5 out of 10. Okay, and in the LRU it was 6 out of 10. That means uh, in this case MRU has performed better than LRU because there are less number of page faults. Okay, and as we all know that whenever a page fault happens, then the OS has to bring the page from secondary memory to main memory. This is when page fault happens. Okay, and this is a very expensive operation. It's a very expensive operation. Okay, and this particular time is called page fault service time. Okay, this is service time. Now now one more thing I want to explain here, which is in general related to the total time that takes for a page, for a CPU to access a page is so you can see that whenever a CPU requests a page, then first of all it checks the page table, okay, which exists in main memory, and then from page table it gets to know the frame number. Okay, it gets to know the frame number, and then CPU using that frame number, using that frame number fetches the page from main memory. Okay, and it will give it the page. Okay, so now here you can see this is your first step and this is second. So this is a scenario in which page table sends the frame number. Okay, sends the frame number to CPU. That means page is present. That means page is present in main memory. Okay, that means there is no page fault. Okay, so now here you can see there is a time to access main memory. So in the first step also CPU accesses main memory. Okay, and in the second case also CPU accesses main memory. So you can see there are two main memory access. Okay, so therefore whenever page fault doesn't happen, then in that case if in the problem you are given that main memory access time is, let's say, 5 millisecond. Okay, then when page fault doesn't happen, okay, then in that case how much time it will take for CPU to access the page. First, it will access, as you can see, it will access the page table, which also exists in main memory. And then using frame number, it will access the page, which also exists in main memory. So there are how many access? Two access of the main memory. So here, the when page fault doesn't happen, then there will be two times of main memory access. Okay. And whenever page fault happens, then you don't need to think of anything. When page fault happens, then in the problem itself you will be given a time which is called page fault service time. Page fault service time. Okay, this time is the total time that it takes to even bring the to bring the uh, page from secondary memory to the main memory, uh, and also the time to put back the page from main memory to the second memory. Okay, so this is the page fault service time which will be given to you in the problem. So your effective memory access time formula becomes so total page fault into, so whenever page fault happen, then you have to count page fault service time. Okay, plus so total reference minus page fault into so whenever page fault didn't happen, for that 2 into memory access time divided by total page references. Okay, so this is your ultimate effective memory access time formula. Okay. Yeah. So in this lecture, we talked about MRU and LRU.